Here's my implementation of the rock, paper, scissors project. As you can see, I made it as a website instead of using Java, so this is written in TypeScript, which was compiled to JavaScript. Here I made 3 different modes, but the only interesting one, and the one I spent the most time on by far, is this last one, Psychology PhD mode. That's the one I'll demonstrate first. Basically, this one's interesting because each time you play a game, it stores that in its memory and then tries its best to find patterns in your behavior to exploit. So for example, if we try a very simple pattern of playing paper every single time, see, first it plays rock, then it plays paper, and then the third time it realizes that scissors does well against you, and from now on it will stick to scissors, and with this strategy you'll never lose another game. So after 3 rounds it was already optimal for this strategy. If we play instead something like deciding to play paper and then rock, and then paper again, alternating, now to combat that it needs to remember what round was played previously. So it can't just rely on which option has the highest win rate overall. So here we win, we lose. First it gets stuck on this tie idea for a bit because it sees that it plays better than if it was choosing rock here, but then it realizes that scissors is a good idea and just sticks to that. So after around 10 rounds it's able to learn your strategy and never lose. And how this works is that it remembers how successful it is with paper in general, but it also specifically remembers how successful paper is after a round of scissors paper. So here it sees we got scissors paper, and it knows after scissors paper, playing paper gives it a very high win rate, which is why it will pick it for this next round. It also knows that after a round of paper rock, playing scissors has a really high win rate. So right now, if we play rock instead, we'll counter at scissors and we win. But of course that's inconsistent with the strategy earlier. Now what if we choose like an even more complicated system of logic for our gameplay? Let's say we're going to choose the winner of the previous game. Or, yeah. So if we start with paper, here here paper's the winner, so we'll play paper again. Here scissors was the winner, so we'll play scissors. And first it gets stuck with the tie for a bit, but ties are actually considered slightly worse than the default, so it won't get stuck on a tie forever. Here we win, so we'll keep playing scissors. Then it finally discovers rock. This time we lost against rock, so our strategy is going to be to play rock now. Here we won, so we're going to keep playing rock. And right now our win rate is still quite a bit higher. Now we lose, it discarded paper against rock. So paper is the winner, we're going to play paper. Now scissors. See, but this time it learned a lot quicker. So it's catching up. Even in terms of win rate, it's catching up. So rock. There. Scissors. Rock. Okay, it learned switching from rock to paper instantly. And now, nope. There. So it's already learned our strategy. And now we'll just run into the same loop of choosing the winner, which is what it played last time, because it's winning every time. and it can counter you preemptively. So that was like 20 rounds, and then it lost. And this strategy, if we like switch it up for one move, so play scissors again. Oh, scissors won. But now we have to play rock again. And it quickly gets back into the pattern. So some short-term straying or delegation from your strategy doesn't mean that it'll get permanently messed up. It still has all that memory of how you played before. However, so first of all those three strategies, I didn't hard code any logic for them specifically. It just has this general purpose rock, paper, scissors brain, and any kind of system of logic would eventually fit into it. But those three strategies are pretty simple. You could like write a few rules down and then come up with the expected output every single time. But then what about human psychology? So humans don't naturally just think of, oh, I'm going to play rock at this moment and then paper at this or whatever. They just intuitively come up with a move to play. So subjectively, you perceive it as being random, but you actually can't make anything particularly random at all. So if you kept playing and playing and playing, your patterns would start to emerge, and the AI. Wait, actually, I don't know enough about the definition of AI to know if this is considered that. No, it's not an AI. It's just this algorithm will eventually find your patterns, and it will be able to surpass your win rate, even though you feel like you're playing randomly. If you actually played randomly, like using a random number generator, here, like if we did 1, 2, 3, 3, and then just played with this, then our win rates would be identical over time, because neither of us will have, well, maybe even if they have a pattern, it's not going to matter because we're doing it randomly. But yeah, eventually you'll have a win rate that's higher than yours if you keep trying to play randomly, because human psychology is not completely random. But that pattern is a lot more complex than the ones I showed before, like copying which option won the last round. So it would take a lot more rounds for it to figure it out. So I'm going to time-lapse the video, or speed up the video, and then just try to play randomly so that you can eventually see how it's able to predict my intuitive decisions. And here I'm not going to be like consciously thinking of what pattern it will use to try to mess it up. I'm just going to try to pick somewhat randomly and see how long it takes for the algorithm to figure it out. So as you can see, the win rate of the computer isn't extremely impressive. Like 58 isn't that far from random, but you have to consider the number of rounds. Like if it was 10 rounds, then having 60% or something isn't much, but here it's more credible. You know that it's not just a random coincidence. And I'm guessing that improvement is going to be diminishing. So maybe after a few million rounds, it would get up to 80% or something like that. But for now, you just have to settle with it being slightly higher than that of the player. Still, I think it's kind of impressive that any algorithm can be better than the player consistently. Like even if you're slightly luckier or unluckier, I don't think you can get to 350 rounds and be at a higher win rate than the computer is, unless you're really analyzing the positions better. Okay, well, the first two modes aren't that special. Random is what you'd expect. It picks random options without considering anything else. Except scissors, apparently. Okay, there. Then Redditor mode, it exists to only counter a specific strategy of choosing the winner of the previous round. So here the winner is rock, and if we pick rock, we'll lose. Here the winner is paper, we'll lose. If we pick something random, here the winner is rock, so it will pick it again and it loses. Or, well, we lose. And the idea is that this kind of strategy is pretty intuitive, so many people might do it without thinking, and then the computer's win rate would be higher, at least until the player figures out what's happening.